Nakoto Akutawira. Welcome back to this video lesson on the standard normal distribution. Now, one thing that makes normal distributions challenging to compare is that they change depending on where the mean is and depending on how spread out the data is. And again, that measure of spread is the standard deviation. For example, in this video above here, we've got the red and the purple. Let me just get to that one. The red and the purple right there. They've got the exact same mean. We can see there their mean is the same, but the purple one is way more spread out compared to the red one. Okay, so where the red one is much narrower and taller, so the red one is less spread out, suggesting or stating that the red one has got a smaller standard deviation compared to the purple one. Now, the red one and the green one, remember that this axis is a ruler. It's a number line. So as we go more and more to the right, the numbers are getting bigger and bigger. So this red one has a much, much smaller mean compared to the green one, but they've got the exact same standard deviation because we can see they're spread out about the same. And the last one here, this blue one, has got a mean that's in between the red and the green, and it's also more spread out, so it's got a larger standard deviation compared to the rest. Now, what we're going to do to make these easier to compare is we will standardize these distributions to make our calculations for probability much, much easier. Now, the standard normal distribution is a normal distribution where the mean is 0 and the size of each standard deviation is 1. Because if we had a normal distribution here where the mean is 850 and each standard deviation is 20, that's going to make it challenging to compare to something that doesn't have that exact same size. So you are going to standardize a normal distribution, and that's going to make our probability calculations much, much easier. And that's going to allow us to look up these probabilities in a Z table. Okay, here are some backgrounds. If you see a capital X, that indicates a normal distribution that has not yet been standardized. Once we see a Z value, that indicates a normal distribution that has been standardized. Please add those two lines to your notes. Now, Z scores or Z values are going to be used to calculate probabilities by using a table. This table will be provided to you. And a Z table tells us the probability of a measurement lying between 0, which is right at the mean, and Z, standard deviations. And we're going to write that as the probability of 0 less than Z. Okay? And really important to mention that the Z table tells you the probability of being between 0 and Z standard deviations from the mean. Please add this to your notes. The Z value tells you the probability of being between 0 and Z standard deviations from the mean. So if we wanted to find the probability being between 0 and 0.625 standard deviations from the mean, you follow these steps. Here's our table. We're looking for 0.625. This first column is the Z value. So the probability of being between 0.625. You go down the column, there's my 0.6. This row is the second decimal point. So 0.62. Find out where they intersect. And then 0.625, here's my third decimal digit, the 5. And what we're doing is, this is 0.2324. This 16 is actually 0.0016. So that 16 is added to that 24, and that gives us the probability of being between 0 and 0.625 standard deviations from the mean. Those add up to 0.2340. So that's the probability of being between 0 and 0.625 standard deviations. We've got more of these coming up. Thanks for watching. Be right back with the second half of this video.